Hello, so I have a homework problem here for you. I know you've seen a lot of these, and so just in case you need some help with this, here we go. We're supposed to find f plus g, f minus g, f times g, and f divided by g. And what I'll do is I'll just do a separate page for each of these. But after that, we're supposed to find the domain as well, and that might be where bigger questions occur. So first we want to add, so I'm going to add 2x divided by x minus 9 to 3 divided by x plus 4. Now that is the two functions added together. The problem is it's not simplified. So 9 times out of 10 when you're asked to do a problem like this, they really want the answer simplified. And the problem with simplifying this is you're adding two fractions together, right? Well, when you add two fractions together, what do you have to have? Of course, you have to have a common denominator. And that's where all the work comes into this problem. So what am I going to do to find a common denominator? Well, I'm just going to multiply these two denominators together. They don't have any common factors. They are completely factored at x minus 9, doesn't have a common factor with x plus 4. So I'm going to multiply the second fraction by x minus 9 divided by x minus 9, right? Because that's equivalent to 1. And over here, I'm going to multiply by x plus 4 divided by x plus 4. Why? Because that fraction is equivalent to 1 also. So when I multiply these individual fractions by this, what we call a unity fraction, I'm not changing the value of the fraction, just the way it looks. Okay, so what am I going to do next? Well, I'm going to leave this big old denominator, x plus 4 times x minus 9, just like that. I don't want to multiply out factored denominators. There's not really a lot of value in that. But the numerator, I do need to simplify. So what am I going to do there? Well, you know what? I'm going to distribute this 2x in times the x and then times the 4. What is that going to give me? Well, 2x times x we know is 2x squared, and then 2x times 4 is plus 8x. That's stuff you learned in your previous math class, okay? But we're still practicing it here, no doubt. I'm going to do the same thing on the other side. I'm going to distribute this 3 inside both of these terms. So 3 times x is 3x. Now this plus, I'm going to put in the middle because this addition applies to both of these. Now when we do the second problem, the subtraction problem, we're going to have to be super careful about that. And we're going to do some of the same steps. So 3x times x is 3x. 3x times negative 9 is negative 27. You with me, right? Now I'm going to add like terms. So I'm going to scoot over here for space purposes. I got 2x squared. Those two middle terms are like terms, so plus 11x and then minus 27. That's divided by my factor. Don't multiply out those denominators. When they're factored, they're happy factored. Leave them factored, okay? Now, this very well may be your answer, completely simplified. But here's the deal. If, by chance, this numerator factors 2x squared plus 11x minus 27, and one of the factors is either x plus 4 or x minus 9, we have to factor it and cancel common factors. Now, with a little bit of looking at this, we realize this doesn't factor. What am I do to figure that out? Well, one way to do it is using what we call the factor by grouping method. If I multiply 2 times negative 27, this leading coefficient times this negative 27 down here, the constant, I get negative 54. And there are not two numbers that multiply to be negative 54. In other words, have a product of the a times the c value and also add to be 11. That's how I know this thing doesn't factor. Okay, so it takes some thought. It's not as fast as what I just said. It takes some thought, but that doesn't factor. What does that mean? That means this is the final result for f plus g. Now let's talk about the domain. Now here's the deal. When you look at domain, my suggestion is don't look at the simplified version. Go back to before you added these together, before you simplified. So way back up here before I found a common denominator. Notice I'm writing at the top of the screen now. 2x over x minus 9 plus 3 over x plus 4. Well, look, if you find the domain of each of these individually, you know that 2x over x minus 9 is undefined at x equals 9. I can't plug 9 in here. Why? Because it makes the denominator 0. So we know that x is not equal to 9. What else? Well, x better not equal to negative 4 either, right? Because if I plug negative 4 into this second fraction, into the g function, I get 0 in the denominator. What's wrong with 0 in the denominator? You can't do it. It's undefined. You can't divide by 0. If you need a longer explanation of that, hey, just shoot me an email. I got a good one, okay? It just takes a few minutes. Now, this is the domain, but that is not in interval notation. So the domain in interval notation means what can we plug in versus what can we not plug in. Well, we can't plug in 9 and negative 4. If you look at that on a number line, here lives negative 4. That guy is out. Can't plug that in. Here is 9 somewhere over here. That guy is out. You can't plug that in either. Well, what can we plug in? Everything in between. So here, oh, and on the other sides too. Let me make that clear. This is what we can plug in. So my domain is right here in pink, which is negative infinity to negative 4, parentheses, because I can't include the negative 4, union, negative 4 to 9, another parentheses, because I can't include the 9, union, 9 to infinity. So this is the domain of my function with extra negative 4 and 9 at the top of the rectangle there. So this is the idea. I'm going to reproduce this idea 3 more times. These problems take a long time, folks. I apologize, but I need you to try all of these a few times so you really get the hang of it. Next, I want to do f minus g. All right, what is that going to look like? Well, a whole lot like f plus g, except we're subtracting, right? So I'm going to start with f of x, which is 2x over x minus 9, minus g of x, which is 3 divided by x plus 4. What do I have to do to combine those together? I have to find a common denominator, right? Just like we did in the addition, which means I've got to multiply this dude over here by x minus 9 over x minus 9, and this guy over here by x plus 4, sorry for the tiny writing, over x plus 4, because those are unity fractions. I'm going to be super careful when I distribute, because that's where a lot of silly mistakes are made, and I'm going to be super careful with this minus sign. Okay, so watch this. I've got 2x, then I'm going to multiply times x and x plus 4. That's the distributive property, so it's 2x squared plus 4x minus, right? Because there's a minus here. Now, if I just distribute this 3 right now, I'm going to get it wrong, because I need some brackets. I got to minus this whole result right here. So that's going to be 3x minus 27 when I distribute. But that subtraction sign between has got to distribute inside. Y'all guaranteed that's the thing that people miss all the time. Please be careful with the minus problems, okay? So I distribute that negative inside. So the negative is going to make that a negative 3x, and this negative is going to make that a plus 27. All right, so here we go. I got 2x squared, this 4x minus 3x, and then plus 27, just like I promised, right? Over, don't multiply out denominators when they're factored. They are happy to stay factored. It's very rare that you ever need any math where you multiply out denominators. It's not never, but it's rare. Okay, 4x minus 3x, that's x, right? So now I've got 2x squared minus 1x, which is just minus x, plus 27, divided by my factored x plus 4 times x minus 9. Now, that may be our final answer. As long as this numerator right here does not factor into either an x plus 4 or an x minus 9 factor. So we do have to check it, y'all. So I need numbers that multiply to be 2 times 27, 54, but also add to be negative 1. Are there a single unique pair of integers that multiply to be positive 54 and add to be negative 1? And I argue that there are not. You can go through all the multiples of 54 and you're not going to find them add to be negative 1. It's impossible. What does that mean? That means I am at my final answer for subtracting these two functions. Now domain, remember domain, you got to go back and look at the original function. I'm going to write the original function at the top of the page. What I mean by original, I mean before we actually did the subtraction. So 2x divided by x minus 9 minus 3 over x plus 4. Before we simplified. What's the domain of that? Well, x cannot be 9. X cannot be negative 4. If you watched the first part of the video and we added, same thing. So what does that mean the domain is? Same as it was for A. So that's going to be negative infinity to negative 4. Because it can't be negative 4. Union, in between those two guys, negative 4 to 9. Union 9 to infinity. If that doesn't make any sense, go back and watch the plus one that I did just a couple of minutes ago. So that is your domain. All right, let's do it again. Let's multiply these two functions together. It turns out multiplying rational functions, which are fractions, y'all, together is easier than adding and subtracting. So here I go. I'm going to multiply 2x over x minus 9 times 3 over x plus 4. You don't need a common denominator to multiply functions together. You just multiply the numerators together. 2x times 3 is 6x. And you multiply the denominators together. But remember what I said about denominators? Leave it factored. There is no reason to FOIL all that out in a denominator, because the ultimate goal is to factor the numerator and cancel. Well, y'all, that numerator is factored, and neither of these factors, either a 6 or an x, cancels with an x minus 9. So that is completely simplified. What is the domain? You can look at right here before we simplified and realize that denominator cannot be 0. Remember, that's the important thing. There's 3, maybe 4 ideas of finding domain. One of them is denominators can never be 0. Another one is you can't take the square root of a negative number. And then the other idea is that polynomials have a domain of all real numbers. And these aren't polynomials because they have denominators, okay? So this domain is just like the first two. It's going to be negative infinity to negative 4. Why? Because x cannot be negative 4 because of this factor. Union negative 4 to 9. What's up with 9? Well, x can't be 9 because of this factor. Union the other side of the number line, 9 to infinity. Parentheses are important. That means that those numbers are not included. Anytime you have a parenthesis next to a number, that means that number is not included. A bracket means the number is included. Now let's look at the last one, the division. Okay, so for division, what's up with that? Sometimes you got to be extra careful with division. Because you have extra denominators going on. Can be a little confusing, I know. This says f divided by g. That means f's on top, g's on the bottom. So let's write that down. That's 2x divided by x minus 9 divided by 3 over x plus 4. Did you see that little trick I did there? I made the middle fraction bar a little bigger. That's to remind me this is the big fraction, okay, and we're taking this function f of x on top and dividing by this function f of x, g of x on the bottom. Now, how do you divide fractions? Remember the rule. Some of you know it as keep, change, flip. Some of you know it as multiply that by the reciprocal of the denominator. But no matter what, you keep the top the same, 2x over x minus 9, and you invert the denominator, or you flip it upside down, x plus 4 over 3. Now, everything is factored at this point. So if I had any common factors, for instance, if 2 and 3 would cancel, I would cancel them. Somebody's going to say eventually, can't you cancel this x with this x? Nope, right? Because you can't cancel part of a factor. You either cancel the whole x minus 9 with another x minus 9, or you can't touch it. Same thing with the x plus 4 or the x. So, simplified, what do? I argue that you could leave this completely factored. 2x over times x plus 4 divided by 3 times x minus 9. I am perfectly happy with this answer. If the homework doesn't accept it, then poo on them. I think it's right. But if they don't, and they say that that is not simplified, what would you try to do? Well, distribute. So in the numerator, you could say that's 2x squared plus 8x. And in the denominator, if you really want to distribute it, 3x minus 27. But I don't believe there's any point in that. And I also don't think it's probably necessary for the homework. But I can't guarantee you that. Different homeworks, different textbooks handle that different ways. And I'm pretty sure this is what I typed in when I practiced the homework, and they accepted it. Now, what about domain? Okay, so remember, denominators can't be 0. Now look, you have lots of denominators going on, right? You have, when you look at before you simplify. Don't look over here, y'all, at this simplified one. Go back to right here before you simplify. What's a denominator? Okay, what's in a denominator? Well, I have a denominator right here, right? So I know from that automatically that x cannot be -4. I also have a denominator right here, okay, because I would take 2x and divide it by that number right there. That means x cannot be 9. But you know what? I have, in a different color, here we go, an even bigger denominator. Look, I have a denominator right there also. So 3 over x plus 4, that cannot be 0 either. So I'm going to have to just calculate that. So I'm going to say 3 over x plus 4 cannot be equal to 0. Well, if I try to solve that by multiplying both sides by x plus 4, 0 times x plus 4, right? That gives me 3 is equal to 0. That has no solution. Okay, so what do I end up with? Well, I end up with the idea that x cannot equal -4 and x cannot equal 9. So my domain does match the original domain that we've been calculating all along. But sometimes the division domain can be different, y'all. Be careful. Okay, so that's like a really fast version of that. And again, I know these take a long time to do because they're asking you like 8 different questions. But it makes you really good at this, and I need you to be really good at this. Okay? All right. Have other questions? Just send me an email, and I'll be glad to make a short video or send you hints in an email. Have a great day.